page 53. So this is the factor theorem. We had the remainder theorem yesterday, where we could evaluate a function with synthetic substitution. Now we're going to look at the factor theorem. So this is what your factor theorem says. It says, given a polynomial f of x, x minus c is a factor if and only if f of c equals 0. So I want to talk about a couple of things with that. First of all, this phrasing, if and only if. Right? So one of the things that you talk about in geometry are conditional statements. If-then statements, you have conditionals, converse, inverse, contrapositive. Hopefully that at least sounds familiar to you. And that's an important part of it, because one of the big things you should get out of geometry is not just about shapes and stuff, but it's the logic behind it and the critical thinking and the structure of statements. Okay, that's a very important part of it, because you need to understand how to read them. This if and only if is what's called a biconditional. So that means it can be read in both directions. So one thing depends on another one. So f of x minus c is a factor if f of c equals 0. And if f of c equals 0, then x minus c is a factor. So you have to look at, you can look at it both ways, and that makes a difference. You have to understand how to read those statements, especially when you get into calculus, because sometimes you have to go back to like, okay, what does it actually say? Can I actually apply that at this point? So this is what's called a biconditional. That means one determines the other and vice versa. That's kind of what if and only if means, and vice versa, right? Because it works both ways. So this f of c equals 0, that's the synthetic substitution we were doing yesterday. So if I do my synthetic division and my remainder is 0, that means this is a factor, because that means the function value is 0, which is what we would want. It's like an intercept, right? But if it's not, then that's where we're evaluating the function. So all you have to do here, still doing synthetic division, and you're just trying to decide it. You just have to figure out whether or not you have a 0 as a remainder. So it says, use the factor theorem to determine which binomials are factors of the given function and check all that apply. So they've given me 3 linear factors over here, and I got to decide whether or not those are factors of this. I could try like factoring this stuff and do a lot of things, but I don't need to do any of that. I'm just going to use my synthetic division. So when I do that, what goes in here is 1, negative 31. Does negative 31 go next? No, what goes next? 0. Good. 0, negative 31, and 30. All right, so if I'm going to check this first one, what goes on the outside right here? Negative 1. Okay, so yesterday we were plugging in the number we saw because it would say like c equals whatever. But this I have to solve it, so it'll be negative 1. Here's where my remainder would go. And then I just drop this down. Negative 1 times 1 is negative 1. I just combine these, get negative 1. Negative 1 times negative 1 is 1. I combine these, and I get negative 30. Right. So negative 1 times negative 30 is positive 30. So though that looked a little hopeful, my remainder is 60. Okay. So is x plus 1 a factor? No. So we're going to say x plus 1 is going to be a no. So then I'm going to go on and try the x minus 5. So I'm still using 1 and 0 and negative 31 and 30. And what goes on the outside? 5, a positive 5, right? Bring down my 1. It's 5, 5. 5 times 5 is 25. This would be a negative 6, negative 30, and 0. So is x minus 5 a factor? Yes. So I'm going to say x minus 5, and then yes. Now, when I move on to check, so I'm going to check it. Yes, that one works. When I move on to check the next one, I'm starting this a little bit differently. Because if I write this out, okay, so I'm going to write out what's happening right here so that we kind of understand what happens. If this x minus 5 is a factor, then that means that x minus 5 times, what would this give me right here? That would become, well, just this right here when I rewrite it as an equation, x squared plus 5x minus 6, right? So that's what f of x is now, right? I've factored it a little bit. Does that make sense to you? So when I want to see if x plus 6 is a factor, well, x minus 5 already is. So see how I reduced this? If x plus 6 is a factor of the whole thing, it also has to be a factor of this part. You agree with that? So instead of using this right here, like I did here, I mean, I could, but it's going to simplify things if I don't. I get to use my reduced version. I didn't get to use this because it didn't work, but this works. So now I'm going to use 1, 5, and negative 6. And what goes out here is negative 6. And then I have less numbers, and they're smaller too, right? So I bring down my 1. This gives me negative 6. That's negative 1. This would be 6. This would be 0. So what happens with x plus 6? It is, yes. So x plus 6 is a yes as well. So what I know now, okay, does that make sense? Tell me if it doesn't, because you're probably not the only one. But let me finish writing this stuff. Since I have that x plus 6, what does this leave me with right here? X minus 1. So do you see how, as we did this, we got it factored? We got to use this part here because x minus 5 is one of the factors of that. It reduced it down for me. So could I have used the original? Yes, but there's going to be times where you don't want to do that because you want it to reduce down. You only get to do that once you have a remainder of 0 and to try it. Does that help? Any questions about that? Ask me a question. Where are we? X minus 1 I got from right here. I was just writing it out. Okay. Anything else? See, even when you don't ask me a question, I can tell by the look on your face. What the heck does that mean up there? Are we good? Anything else? Because please ask me. Don't be afraid to. There's not that many of you in here, so I know sometimes you're just afraid to ask. Nobody's going to make you feel stupid, I promise. And even though there's so few of you, you're probably still not the only one thinking whatever it is you're thinking. All right, we good? Oh, these are my answers right now. This actually isn't asked. We're going to do this part on the back because it say find it and fully factor it. So we didn't have to do this right here. I just was so I could kind of show you where things were coming from. Okay, that's a good question. Anything else? So do you understand, right here, do you understand you don't have to do this? I was just showing you why it worked, that's all. Okay, so let's look at this one. So now I'm going to test these, right? So I'm going to start with that x minus 2. So let me write these down in here. I've got 1, negative 6, negative 17, 78, negative 56. Where does the 0 go? At the end, yes, good. Negative 56 and 0. All right. And then outside, we'll start with that 2. All right, so this gives me 1, 2, negative 4, negative 8. Be careful with your signs because that's where a lot of these mistakes happen. Negative 25. It's 2 times a negative 25. Negative 50, right? So this gives me 28. 2 times 28 is 56. That's 0. So 2 times 0 is 0. And then 0. So yay. We get that x minus 2. Oh, that's not a 2. X minus 2 is a yes. So when I move on to the next one, I'm going to use the reduced one. Because if you don't, the numbers get even bigger and weirder, because trust me, that's what I did the first time because I wasn't paying attention to what I was doing. And if you use this one again, basically you're going to kind of regret it because the numbers get icky. And then I can use the reduced one. Only because this was 0, so that's why I get to use this right here. So inside here, I'm going to have 1, negative 4, negative 25, 28, and 0. And that 0 is important, so make sure that you're using your placeholders because that's a very common mistake. On the outside, we're going to have the negative 7. So bring this down. This is 1, negative 7, negative 11. 7 times negative 11 is what? 77. So 77 minus 25, 52. Positive, right? And then 52 times 7, 364. You agree with that? Did I do something wrong somewhere? I feel like my number's wrong. Okay, no, we're good so far. Okay, it is 364. Sorry, I was just thinking to myself, like, because I know I don't have it right on my paper because I did weird things. I got 364, and it's negative, right? All right, so that negative 364 and the 28. I can subtract 30 and add 2 back. Would you agree with that? It's an easy way to do it. So 364 minus 30 is going to be 334, and then I add 2 back, and that's going to be a negative 336. So then when I multiply negative 7 times negative 336, I know the number that goes here is going to be positive. Let's do this in pieces. What's 7 times 300? 2,100, right? Because 7 times 3 is 21. 7 times 30 is 10, right? And then 7 times 6 is 42. So if you just jot those things down, 2352. Now, does it even matter what that number actually is? Because it ain't 0. That's all that matters, really. And so this is 2352 because what we're really looking for, in this case, the remainder didn't matter to us. We just needed to know whether or not we got one that was a 0. So this x plus 7 factor is a big fat no, right? And they would have gotten worse had I not used the reduced ones. So think about if we were using these numbers. It was leaving the x here. So now I'm going to still, do I get to use this here? No. Do I have to use this? No, I can still use that reduced one because I hadn't taken anything else out of it. So in here, I'm going to have 1, negative 4, negative 25, 28, and 0. On the outside, I will have a negative 4. This is 1. It's going to give me negative 4. So that's negative 8. Negative 4 and negative 8 is a positive 32. This is going to give me a positive 7. 4 and a 7 is a 28. It'd be negative 28. So that's 0, 0, 0. So x plus 4 is a yes. Okay. Any questions about that at all? We're good? All right, so that's how you test if, say, hey, does this factor work? That's what we're looking for. We're going to skip number 3 because we don't need to do all of these examples on here. I want to jump to number 5. So go to number 5 on the back. And we always want to make sure that you're reading your directions because we're doing a lot of things that are similar to each other, like the similar steps. So make sure you're doing the parts and the pieces that you're supposed to be. Oh, but the directions on number 3. Sorry. Oop, there you go. So it says, use the factor theorem and the given binomial to completely factor the polynomial function, then give the zeros. So we got to give the zeros. But one of the differences between these two things, here, did you know whether or not these were factors? No, that's what we're checking, right? Is this a factor? Yes, it gives me that, right? And it's telling me this is a factor. That's an important thing to recognize. When you do your synthetic division, what do you expect your remainder to be? 0. And if it's not 0, you did something wrong because they're telling you it's a factor. You see how that works? So if I know it's a factor, I know I'm supposed to get 0, but I still have to do it because I need the answer that I get. So let's look at number 5. This is the given factor. So I know on the outside is going to go 7. On the inside, I'm going to have 2, negative 7, negative 53, and 28. So then I'm not testing it here, I'm doing it to get the result. So I bring down my 2, and then I get 7 times 2 is 14, gives me 7. 7 and 7 is 49. So I get negative 4, right? 7 and negative 4 is negative 28, and I get 0, which should be no big shock. I expect to get 0, and I needed to do this to get 0. So when you have done this before, when you were just straight up doing synthetic division, your answer was this that you just then put into a polynomial, right? But we're not just dividing, we're factoring. So at this point, what I have is f of x equals this factor that I used, x minus 7, times this that I'm remaining with. So this was x cubed, which means this is the coefficient for x squared. So this gives me 2x squared plus 7x minus 4. Everybody with me so far? Now I need to keep going, right? So could I do synthetic division again to reduce this down? What would I use on the outside? Well, it's a possibility, right? Do you even know where to start guessing? You really don't, do you? There's like an infinite amount of choices. So I really don't want to choose from infinity because I could be here a while. Now, we will learn how to narrow things down and have a list to choose from. We don't know that right now. So if we did know another one, we could do that. But I don't. So I don't get to do synthetic division again. So what am I going to have to do here? Factor. I'm going to have to factor again. And when I ask y'all questions like this, I need you to be honest with me because I'm not trying to call anybody out. I just need to know if I need to work it out or not. Is anybody still having trouble factoring something like this when A is not 1? Okay, so no, nobody wants. Okay, so go ahead and factor this part. Actually, come over here and just factor it over here. Get that factor. Let's make sure it's factored right, and then we'll go substitute it back in because I don't know if you necessarily have enough room in there. Oh, you're on the right side of the paper. Get up. After you factor this correctly, can you factor that correctly? Well, when you multiply those back together, are you going to get that? Is x times x 2x squared? Okay. What do you know? I was right. Remember to check yourself, okay? You've got to check it after you factor it to make sure that it's going to multiply back, okay? I think some of you are losing yourself in the steps or not doing them all because you're trying to do what some people call divide and slide, but you're not finishing it off. So I would not continue to do that if you continue to make the same mistakes. So here is I'm going to talk you through the grouping one more time just in case. So if I do 2 times -4, I get -8. So I need two numbers that are going to multiply to give me 8 and combine to give me a positive 7. So that would be a -1 and a positive 7. So then I've got to factor by grouping, right? Out of these two, I can factor out a what? Oh, wait, something's not right. Oh, that should be an 8, duh. Thank you. Doesn't make any sense. All right, so I can factor out a 2x. That makes a lot more sense. And that leaves me with x plus 4. What do I factor out of this? -1, x plus 4. So that's going to give me 2x minus 1 times x plus 4. Which you do not have to do grouping to get there. If you have a different way and it makes sense to you, fine. I'm happy with that. Just make sure that you're doing it correctly. And then once you think you have it factored, make sure that when you multiply these two, you actually get that. Because if you don't have a 2 in there, that's a problem. And that these two multiply and give you this. And then when you multiply and get 8 and -1, you get the 7. Like you need to check yourself every time until you're so comfortable with it, you know you don't have to. Okay? Does that make sense? So now this part right here is just replacing this. So I'm going to substitute this in. This is x minus 7 times 2x minus 1 times x plus 4. Can I factor this anymore? No. So when you think you're done, you can't just leave it like this, because this is just an expression or like an unfinished equation. What does it equal? Does it equal 5? Does it equal 20? I don't know. Well, what it equals is f of x. So make sure you're actually labeling your stuff there. There is my fully factored form, which is something you need. And then I need my zeros. So what would my smallest one be? -4, and then 1/2. And then 1/2, and then 7. And there you go. Okay, everybody okay with that? All right, we're going to skip number 6. Ask me questions if you have questions. Skip number 6. I want you to do number 7. It comes after 6. So do we all get that far? Yes? Any questions at this point? All right, so when I go to factor the rest, what should be the next thing I do? Factor out the x, because I got a GCF here. So I'm going to factor this x out of here. I'll bring it out to the front. So this gives me x plus 5, which leaves me with 3x squared minus 10x plus 8. Okay, so now go ahead and factor that last part there. Remember when you're deciding on your factors? So for 24, 2 times 12 is 24, right? And 12 minus 2 would be 10. But are those the two numbers that I use? No, because this is positive, which means the signs have to be the same. So this would have to be negative 6x, negative 4x. Okay, or if you didn't do grouping, that's fine. But so then this gives me 3x times x minus 2, and then negative 4 times x minus 2, which gives me 3x minus 4 and x minus 2 as my numbers. Just remember, look at those signs. It helps you narrow down your options there. So 3x minus 4 and then x minus 2. Now, very common mistake that can be made here is to not use all of your zeros. How many zeros are you going to have? 5. Yeah, this guy right here, he gets forgot about a lot. Don't forget about him. It makes him very, very sad, right? That's a bad thing. Don't forget about him. It's the easiest one, right? We definitely can't forget about it. So but my smallest one would be -5, then 0, then what? Is it 3/4 or is it 4/3? 4/3. Be very careful with that. That's the next most common mistake. Is I know you know what to do, and I'm not making you write this stuff down anymore, but you may need, in some cases, to write that down so that you get the right thing, and that's where you get the 4/3 from, and then 2. Oh, I said 5. There's only 4. I'm sorry, I can't count. Oh. There's 4, not 5. I can't count. But we can't. Still, some of y'all still forgot about 0. I don't care if I can count or not. All right, are we good with that? Now, I was going to have you do number 8. We're not going to do number 8. I'm just going to talk you through the factoring of what happens so that when it comes up, like I think you can do the synthetic division. You can probably do the factoring and stuff too, but instead of giving you time to think about it, I just want to make sure you have the example written down. So after you do this part, which we're skipping, you end up with f of x equals x minus 3 times 4x to the 4th plus 13x squared. Oh, that's minus 13x squared. Minus 13x squared plus 9. All right, so then when you go to factor this, it's a 4th degree polynomial, but it's set up where you can treat it like a quadratic, right? So if you can factor a quadratic like that, you can factor this. So I'm just going to give you the factored form of that. It's x minus 3, because I know you could do it if I gave you time, but 4x squared minus 9, and then x squared minus 1. Okay, that's what you would get when you factored this if you just treat it like a quadratic. So you can just kind of take my word for it. But then at this point, can I factor this more? Yes, and that's what I want to make sure that you could recognize. That's why I wanted to talk about this one. These are both difference of squares, right? Okay, so I can factor it more, and this is going to give me the x minus 3, and then this 4x squared minus 9, 2x, oh, yeah, minus, it can come first. I'm going to put 2x plus 3, 2x minus 3. It doesn't matter which order. And then this is x plus 1 and x minus 1. Right? So I just wanted to remind you that every step when you stop, you got to say, okay, can I go farther? And can I go farther? And sometimes things factor out very nicely in the end. Okay, we good? Any questions? All right. And then you can find the zeros there too. I'm not going to finish it off, but I just wanted to talk about the factoring. All right. Good deal. Then go ahead and glue that in. Do that now so you're not having to rush through it. Oh, your homework's on the printer. Instead of giving you a second piece of salmon paper, which might confuse you as far as what's due when, I made this. Oh, I messed this up. All right, hang on. I'm sorry. Go ahead and glue that in. I have to print the back.